So the parallel between gravity and acceleration encourages us to explore acceleration on the space-time diagram. So, oops. So let's try to draw some accelerated curves. So that's time, this is space. Of course, if we start at some location x at some moment in time, and we just sit there, that's when we begin to exist, say, at that moment in time, at that location, and we don't do anything interesting. We just move like that, right? So that's zero speed on the space-time diagram, as we know. And if instead we're a little bit to the right of that location at that same moment in time, we begin to exist, but we're moving at constant speed, slower than the speed of light, then our space-time path could be something like that. V, well, let's say V not equal to 0. Okay. Now let's try to get acceleration on the space-time diagram. It's always a little bit tricky because there's so little room to move, because 45 degrees is already the speed of light. So let's say that we start here. How do we want to do this? Well, let's say that we combine these two motions. So for a little bit, we have 0 speed, and then later we will move, I guess, at the speed of light. And so we're moving at speed c, so v equals c here. And here we have v equals 0. And so at this point, we start to accelerate, and we stop accelerating. Or we could continue to accelerate there as well. It just won't have any effect because you can't go faster than the speed of light. It won't have any effect on the speed. But to go from here to here, we have to produce a bend in the curve. So here's an accelerated curve, something like that. Okay, so bending curves represent acceleration. So let's... actually, I don't know that I want to do that. Let's... not sure where I want to put the vertical axis, but let's try this. Let's see where we end up with the vertical axis. But now I want to imagine that I am momentarily in this situation with 0 speed, and I start to accelerate. So I'm bending. I'm going to bend like this, and I can't go faster than the speed of light, so I will asymptote to a 45-degree slope. And so this line here has to, let's just call that, I don't know, A. That's some event in space-time. Let's say that, right, so here, let's say that I'm doing, let's make a symmetric curve. So how do I do this? I'm going to do something like that. And that's a 45-degree line. And so this also ends up there. That's 45 degrees. And right, so the path that I'm traveling now goes like this. So I'm moving toward this location, toward this value of x. Or I'm further away. I'm moving as time goes by, but I'm slowing down. So I'm accelerating. And then momentarily, I'm at rest. So if this is some x and t, then notice that when I am at this location, so here is my movement on the space-time diagram. I'm at different locations. I'm traveling along this path. Well, I'm coming in from here, but I'm just going to draw the events after this t time along that path. Notice that when I connect A to the event that involves me momentarily coming to a stop, let's call that Y1. That's you or me. That's you, your path 1. And this line here that goes through that is your momentary spatial axis. So it's your blue x-axis. And when you get to the speed of light, of course, your spatial axis has now, your spatial axes as you're speeding up are closing in on each other. Sorry, your space and time axes are closing in on each other at 45 degrees. And so this becomes, for here, we just trace this back to here, and we get the x-axis there. And the same thing is true all along, so I can go through this and say that momentarily when you are at this location, this is your spatial axis, U2, let's say, and this could be U or Y3. We could draw through there, and that's your momentary spatial axis, X. And of course, your time axis also bends with respect to this by the same amount as these bend with respect to the x-axis. Okay, so these are your spatial axes, and the thing to notice, interestingly, which we'll use later on, is that event A is simultaneous, right? So event A is simultaneous with event Y1. Right, this is a slice of simultaneity. The spatial axis represents a slice of simultaneity. The same is true here, right? So A is simultaneous with Y2 and Y3 and so on. And so event A is simultaneous with events Y1, Y2, Y3, ... Yn, right? So Yn could be this event here.